Welcome to the lecture on methods of controlling residual stresses in welding. So, in the last lecture we discussed about the different types of residual stresses which occur in the welding, and we also discussed that residual stresses may be beneficial in certain situations and may not be also. So, especially normally it is seen that if it is compressive in nature, it may be more beneficial in certain aspect, but normally when they are tensile in nature and of having larger value, then that is detrimental for the performance of the component. So, we are going to be knowing methods of controlling these residual stresses in the welding process. Now, so first of all, as we see that you have either the positive or the negative effect on the strength of component based on their type, sign, distribution and direction. So, what type of residual stress is there, whether it is compressive or tensile, whether it is reaction stress or thermal stress or mechanical or metallurgical stress. So, that is that. Then how it is distributed, where it is uniformly distributed, or at certain point it is the value is quite high and at certain point it is quite low, whether it is in that type of distribution and the direction of these stresses. So, all these things are basically important to know when we talk about the residual stresses, and it is seen that normally when you have the triaxial tensile type of stresses and when you have its combination with crack like defects, then they are promoting the brittle type of fracture. So, that way they are not desirable in those cases. Or if you have the uniaxial or biaxial type of residual stresses, tensile stresses, then that may improve basically the fatigue resistance. So, that may diminish the corrosion resistance. Fatigue resistance is improved because of the compressive type of stresses. So, that may lead to the increase in the fatigue strength of the material. Now, we also have discussed that many a times when even during the machining process also the specimen are subjected to certain kind of distortion. So, this way there are pros and cons of the residual stresses, and most of the times your motive is to control the residual stresses or the minimize the residual stress. So, you would like to have not residual stress, but which is very difficult to achieve. So, your motive is to basically decrease that value, because when the value of these stresses are high, such as the yield as high as the yield strength of the material, and when there is the combination of stresses from external loads, then that may exceed the design stress value and the material may fail. So, that is why we need to know the residual stresses, how they can be minimized. So, you have to decrease. So, you can decrease in many ways. So, like you can decrease the maximum of the tensile stress level. So, that is one way. Then you can also decrease the zones of high residual stresses. You can have the different techniques by which you can see that those zones where there are high residual stresses, that zones may be free of the residual stresses. or also you can try to see that there is decrease in the degree of multi-axiality of the residual tensile stresses. So, as we discussed that when you have multi-axial tensile stress, and that basically when they interact with certain defect type of structure, then that leads to brittle type of fracture. So, you can have such kind of ways by which you can see that how your you can reduce the level of the residual stresses, or how you can have the ways to so that the job or a specimen behaves better while working. Now, we also should know that we need to be wary of these residual stresses, because if there are residual stresses inside the material, the material is subjected to, they are more prone to go towards the brittle type of fracture. So, brittle type of fracture, why we are emphasizing, because having the brittle mode of fracture is not desirable, in the sense that they do not give proper warning, So, that is why we try to see that residual stresses values are less. Similarly, the stress corrosion cracking, its chances become more. So, when the then similarly the dimensional stability becomes less, as we know that when the stress level will be more, there will be distortion, and that may lead to the distortion of the body. So, you may have the change in the dimension of the material. So, these are the disadvantages, and that needs to be looked into, and for that you have different methods to reduce these welding stresses. Now, the different methods which are normally practiced to reduce these welding stresses are peening, vibratory stress relief, thermal treatment, thermo-mechanical treatment, welding procedure and sequence, materials and design considerations. So, these are the methods which are basically used for removing or for reducing the residual stresses in the welding. Now, peening, what is peening? So, peening means, as we know that peening means you are having the repeated blow with some hammer or mechanical hammer type of equipped with a mechanical hammer, you are putting the blows on that. So, in the peening we are what we do is our purpose is to have the elongation of the outer fibers of the weld. So, when we are doing the welding, at that time we do the peening. So, there will be small deformation at the top portion. So, elongating the outer fibers of the weld with the help of the mechanical hammer blows, and that basically redistributes the stresses. So, this way stress level is basically relieved. So, the stresses are, this is used for relieving the stresses, and then if you can do it with the mechanical, you can do mechanically, you can do manually. So, you will have the hammers by that. So, this is a very common practice in the case of welding. When you do the welding of thick specimen and you do many passes, then except for the first and last pass, what you do is every time you do the welding, some peening is done. So, that is done with either manually, or many a times you have better control with the pneumatic chisel with a blunt round top edge. So, if you have that kind of pneumatic type of chisel, then you can do even better way this peening process. The peening process basically it reduces the internal stresses of very low intensity. So, internal stresses will be reduced of very low intensity, and it will be far below and affected by heating below the critical point. So, in that case the at this low temperature. So, basically the main advantage of this spinning, because it is reducing the internal stress of very low intensity. So, normally it will be eliminating the need for the successive heat treatment when you are welding a very thicker section. So, that way it is advantageous in such cases. It will also reduce the distortion, because here what we do is you are redistributing the stresses. So, the distortion which is achieved because of the larger value of the stress which is reached during the welding process. So, this way the distortion will be reduced by the pinning operation. Now, the one of the precaution which is to be applied during the pinning is that the pinning should not be employed on the first and the last layers or beads of the welds, because when you do basically the pinning on the first layer, then that may actually pierce the weld. So, because you are having a thick specimen, you are putting the first layer, and at that time if you do the pinning or hammering, then in that case it may pierce this. So, it will pierce the weld, and it may displace the weld sideways. So, there will be not proper accumulation of the weld metal at proper place. So, normally we avoid at the first layer, and also we are normally avoiding the pinning on the last layer, that is the top layer. So, that we are avoiding because that may injure the weld metal. So, because if you do there being very hot, and so that may affect that weld metal. So, there is because there is no subsequent application of heat to anneal that last layer. So, we do not do this pinning of the first as well as the last layer. Now, we try to avoid this pinning. This is the example of pinning. As you see, you see that this is we can do with this mechanically. You can do this pinning with hand, and you can have the mechanism by which you can have the pressure which is or blow which is created. So, this way the pinning methods are there. Now, we should try to see that you do not do the excessive pinning, because excessive of the pinning if you do, that may lead to the cold working of the material, because the material cools very fast, and once you do the cooling, that may lead to the cold working, and in that case there may be strain hardening of the weld metal. So, the excessive pinning of the material should be avoided. Apart from that, if you do the excessive pinning, in that case there may be bending also. So, because if you are doing that, because being in the hot state, that may lead to the bending of the weld, or that may lead to even the cracking of the weld. So, these things are there. So, you must also know that when you are doing the pinning, the material must have the sufficient ductility, so that because every time you do the pinning there will be some deformation there going on. So, you are basically controlling that outermost fibers or so. So, the material must be ductile. If it is brittle and if you are doing the pinning, that may lead to again further the formation of cracks. There are more chances of having cracks in that situation. So, you have to see, you have to ensure that there must be proper ductility of the material. Now, coming to the next type of method. The next type of method which is used for the relieving of the residual stresses are the vibratory self relief. So, in this method basically the welded structures are subjected to vibration for stress relieving using an oscillating or rotating wave generator mechanically coupled to the part to be stress relieved. So, by the use of this vibration, the self relief the stresses are relieved. Now, structure vibrates at one of its natural frequencies, and this way the level of the stress which is there, that is basically reduced in such cases. So, they can basically reduce the magnitude of the peak stresses. Normally, they are not the ones which alter the metallurgical properties, because we are not going to a larger temperature or so. So, in that case it does not affect the metallurgical structure of the weld, and that is why the mechanical properties are also not basically altered. So, basically by using this process, that as we discussed, that many a times we need to see that the peak stress, especially the tensile in magnitude or so, we also are thinking of lowering down that peak value of stress. So, this method is helpful in reducing the magnitude of the peak stresses. It will also reduce the distortion in parts, that is which is machined after welding. So, that is another application of this vibratory stress relief for those parts which are machined after welding, and you have some distortion. So, that can reduce this that distortion also. It improves the resistance to brittle fracture. So, as you know that this brittle fracture, that is another challenge which we face. So, it will be improving the resistance to this brittle fracture. So, vibratory self relief that way is one of the method which is considered to be important for controlling the residual stress values. The next method which is used for the reduction of these residual stresses is the thermal treatment. So, in this thermal treatment, basically we are heating the weld structure uniformly to a suitable temperature, holding and then cooling uniformly. So, in this case the strength is improved as well as the toughness of the weldment. Now, in this case as we discussed that there is a predetermined temperature up to which we are heating, we are holding at that temperature, and then further we are cooling. So, just in that process the stress is relieved. Now, the stress is first reduced by the recovery process, and then also by the permanent yielding process. So, I mean, because you have the reduction of the yield strength at elevated temperature. So, then percentage relief of the welding stress is dependent on the type and composition or the yield strength of the steel. So, basically when we talk about the thermal treatment, there are many factors like what is the temperature which you are using for heating, then how much you are holding, and then further the cooling is basically uniformly. So, we have to see that how you are going to cool. So, you have to cool slowly in the furnace normally, and normally you are going to cool up to 125 degree or so. So, what happens that it is normally desirable that the steel structure, for steel structure if you talk about, we are heating to about maybe 600 to 650 degree centigrade, and then holding at that temperature for depending upon the section thickness. So, we are holding for about around 2 hours for every 25 mm thickness of the casting or the welded specimen, and then we are cooling that in the furnace slowly to 125 degrees C or even lower. So, that way and then further we are removing that from the furnace and then cool to the room temperature. So, that is how typically we do this process, and when we are heating to 595 or 600 to 650 degrees centigrade, then that basically reduces the residual stresses rapidly, and also that will remove the undue distortion of the weldment. So, that way it has the advantage in such sense. Now, the temperature which we choose, so that may be different for different materials, like you have for the plain carbon steel, you may go from about 500 to about 750 degrees centigrade. So, that is there, and also that is true for even low alloy steels. So, then for suppose other type of materials, like suppose if you are going to the carbon manganese steels, where the carbon is about 0.2% and manganese is about 1.4 or 1.5%. In those cases, it has been found that if you are going to heat up to a temperature of lower order, then you have to hold for larger duration, and normally when you are heating to larger temperature of the order of 500 or 600, in that case holding time may be about 2 to 3 hours, and then the residual stress levels are normally smaller. So, if you are heating to only 200 or 300 degrees centigrade, in that case the residual stress level may be as high as 33% or so, whereas it comes down to about 10% or even smaller when you are heating to suppose 500 or 600 degrees centigrade and about 3 to 4 or 5 degree hours of holding. So, depending upon that temperature of heating and then holding time, you will have the presence of the residual stresses or level of the residual stresses inside the material at different levels. So, that is how as we discussed that and when you are heating to that temperature at or at the higher temperature, then in that case the recovery will be taking place because of the movement of dislocation. So, that is because of the vacancy diffusion. So, you have the other mechanism of dislocation, climb out or so. So, that way the the material is coming free of the stress. So, that is how the mechanism of so as we know that in the case of that temperature, you will have the removal of the stresses in those cases, and then you have also the permanent deformation at the higher temperatures. So, this way this thermal treatment is practiced for the removal of the stresses. Another practice to remove these residual stresses are the thermo-mechanical treatment. So, in this case what we do is here we use the thermal expansion to provide mechanical forces that sets up contracting residual stresses system and cancels original stresses developed during the welding. So, as we discussed that we have seen that when we are welding two plates, so you have this is welded, these two. Now, what we do is we know that you have the if you take at this section, you will have the tensile stress here, and in this case you have in this region you have the compressive stresses. What we do is normally you try to do this thermomechanical treatment in such a manner that the stresses are developed, so that you will have the tensile stresses developed in this region and the compressive stresses are developed in this region. So, the compressive stress which is there already in that, it will be having some cancelling effect. So, that is why what we do is we are basically moving two bands of heat. So, you will have two flames. So, you will have two flames and they will be moving in this direction here from on both the sides of the weld bead. What we do is we are moving these flames. So, we have two bands of heat, they are moving in tandem along the longitudinal direction of the weld. So, what happens that there will be tensile stresses developed, in this case there will be expansion. So, there will be tensile stresses developed and the compressive stress which is there already in this portion, that is somewhat neutralized. Similarly, you will have the compressive stresses developed in this zone and the tensile stress which is already there, that will be lowered to certain extent. So, that way you try to reduce the value of the stresses up to certain extent. So, this is the example of the thermo-mechanical treatment which is normally practiced. Now, the temperature which is kept in such treatment is normally lower in the lower side and it will be normally from about 170 to 200 degree centigrade. So, it is normally smaller and does not cause any change in the metallurgical properties or improvement in the metallurgical properties, because the temperature is normally smaller. And this is one of the practiced method which is used for lowering the stresses values. Now, we look to the other processes like welding procedures and the welding sequence. Now, what is welding procedure? What should be the welding procedure which will try to give you the lower value of the residual stresses, or it will lower the residual stress. So, normally what is seen is that you use the backstep welding and skip welding. So, we know that when we have studied about these welding processes. So, in this case what we do is that if you have to do the welding of the specimen, then backstep welding and skip welding. So, what we do is normally you are having the tacks. So, you do the tack at different places. So, you will have different zones where, so depending upon the thickness of the sheet, you will have the tack length, and then you will have the different zones where you will be doing the welding. Now, the thing is that in the backstep welding, if this is how you have to do the welding. So, what you do is you do the welding in the backstep direction. So, what you do is you do, if you have to go like this, you go like this. So, this way you do the welding. So, suppose you have to do the welding. So, you do not start from here and finish here. Now, what you do is you will be doing welding here from or here from like this. So, you will be going welding like this. So, this way your welding will go on, that is backstep welding. And then skip welding. Now, skip welding is used because what we do is, once you have the zones defined, suppose 1, 2, 3, 4, 5, 6, 7 and suppose 8 zones are there. In that case, it is not that we are doing from 1 then 2 then 3, or no, not so. So, we may do the first one here, we may do second one here, third one here, then fourth one here, fifth one here, and 6th and 7th, like that. So, that is the concept of a skip welding technique. So, these techniques basically reduce the value of the residual stresses. Similarly, you have the use of the welding sequence. So, how you are taking the sequence of the welding operation. Suppose you have the transverse welds, you have the longitudinal welds. So, in what sequence you will do the welding. So, in that welding sequence you have to know that how you have to proceed, which type of, whether transverse welding is to be done first or the longitudinal welding is to be done first. So, depending upon the type of component or shape of the component, we do the welding, and here the important principle which is applied is that we want to assure that unrestrained transverse shrinkage or large straining length for butt welds. So, for that what we do is, in case of when we have the plate panels, then what we do is and we have the transverse welds which are arranged in a staggered pattern, then to avoid the weld intersection, what we do is discontinuous transverse welds are basically first welded, and then we weld the longitudinal welds. So, first of all we will be welding the discontinuous transverse welds, and then we will go for that longitudinal welds. So, similarly is the practice for the other case. In some cases we are doing for the transverse one, in this case we are doing the transverse one first, and for certain cylindrical vessels, in that case you have the longitudinal welds will be first welded, and then you will have the long circumferential welds that is welded later. So, this way the sequence which is followed for welding the different type of specimen, that is to be taken care of. Then the other consideration which is to be kept in mind is that the material and design consideration. So, in that we must see that the selected material must have a good weldability. So, that if it has a good weldability, then the chances of the stresses and distortion will be smaller. So, anyway weldability defines that. Then important materials which properties which are under consideration are melting point, diffusivity, coefficient of thermal expansion, modulus of elasticity, yield point of material. All these properties, they affect the residual stresses formation in some sense, like if you have, suppose coefficient of thermal expansion is higher, in that case the chances of distortion will be more, residual stresses will may be formed to be more. Similarly, rigidity is more, than the distortion may be less or so. So, this way you will have the different attributes of the different these parameters, and they affect the formation of the stresses and lowering the stresses in that case. As far as the design measures are concerned, then these points are important, like you must go for smallest size weld of smallest length. So, if you have the larger sizes, then there are more chances of having the more value of residual stresses. So, that is why you go for the smallest size weld of small length. Similarly, you can go for fillet weld which will be favorable over the butt weld, and then also prefer the provision of structure into sub assemblies. So, that way you can have you can see that there will be more chances of having less residual stresses, and you will have a satisfactory structure. So, thank you very much for this lecture. Thank you.